Hello, my name is Mark Herman, and this is a presentation that was presented at the 2016 and also the 2017 Cabin Fever Day event at the Urbandale Community School District. It's on certainty-based marking, or CBM for short. Sometimes it's called confidence-based marking. And basically, it's a assessment tool used for students to actually express how confident or how certain they are on their knowledge or on an answer that they have put on a test. It's primarily been used in medical schools and places where it doesn't just matter on what you know, but how well you are confident about your knowledge. It's important for doctors to be very certain and confident about their diagnoses. And so it's been used prevalently in medical schools. It's been highly researched as a good way for people to gain and expand their knowledge. If we look at Bloom's taxonomy, of course, then the hierarchy of knowledge gathering and skills, you'll see that evaluate is near the top. And evaluate is to justify a stand or decision, to appraise, argue, defend, judge, select, support, value, critique, weigh, to examine and reflect upon whether you really do know something or whether you really don't know something. When you know a thing, to hold that you know it, and when you do not know a thing, to allow that you do not know it. This is knowledge. And so it's important as teachers to try to get our students to reflect and think about whether they really truly do know something or not. A lot of times we look at kind of a scale of knowledge, and we started at the top with thinking, okay, this is knowledge. And then we go down and we bottom out at what sometimes we think is just not knowing something. To be able to say, I don't know this. But it actually, the scale of knowledge goes further down. Knowledge is a function of certainty. How certain are you that you know something, and how certain are you that you don't know something? But there are states that are worse than just saying that you don't know something. You could actually be certain that you know something that is not true. And this is why I use CBM in my science classes, because in science there is a particular danger about life experiences of thinking that you really know something to be true based on what you think you're seeing, and it's not true, and so therefore it's a misconception. And a misconception in science can really cause problems. It's really difficult for us to sometimes give up some of our misconceptions that we think we know about. And sometimes those misconceptions can be so ingrained in us that they actually become delusions. We are incredibly certain about something that actually is false. So the scale doesn't go from knowledge just down to not knowing. It goes from knowledge all the way down to delusion. And we start with knowledge being, very certain of what is true. But we can go down, and so we decrease certainty about what is true, and we start increasing certainty about something that's actually false. And so this is important that we teach our students, and students learn, and it's important in all aspects of knowledge, but in science I always feel it's incredibly important, is that students learn how to reflect and to really examine what they know and maybe what they don't know. So what is CBM and how does it work? Well, CBM is basically, you can take pretty much any kind of a test, and generally it's with tests that there's a certain answer to, a true, false, or a multiple choice. But you could do this with essay things too, and it'd probably even be more valuable if part of your essay or half of your essay is, explain something, but then explain why you know that to be true. What's the evidence that what you're saying is true? So you could do it in an essay kind of a thing also. I'm just going to be talking about true, false, or multiple choice type questions. And really all that it entails is to ask a follow-up question or just have the students be able to state their certainty level about that particular answer that they just selected. So here's just a real easy example. We have a question: who painted the Mona Lisa? Just a real kind of a low-level type of a question. And there's different people there. And then you'd choose one, and then you would choose your certainty. I'm not very confident on this answer. I'm fairly confident on this answer. Or I'm extremely confident on this answer. Now, this, like I said, this is kind of a low-level question. In physics, almost all my questions are, entire kind of problems that you have to really work out and figure out some things. The way that this is scored, the important thing is how these things are scored. And there's been tons of research on CBM on the best point values to assign for certainty levels and correctness or wrongness, to make it work out and make students then realize that the best score they could possibly get is if they just learn to reflect better. There's no way of really cheating the system. So the way it works is, if you see up here on this table here, let's just look at if you get it right. So we pick one of these and we get it right. So how many points do you get? How many marks do you get if you get it correct? Well, it depends on your certainty level. If you said, I'm not very certain, and you got it right, you get a point. If you say you're fairly certain and you get it right, you get 2 points. If you say you're extremely certain and you get it right, you get 3 points. So that is the maximum score you could get on any given question. So you can get 3 points on a question if you get it right and you say you're extremely certain about it. What if you get it wrong? If you get it wrong and you said you're not very certain, then you just get 0, like a normal test. If you say you're fairly certain but you get it wrong, you actually get a -2 added to your test. So yes, CBM test, you could end up with a negative score overall. That is possible. And at the beginning, when I first give my first CBM exam, I get tons of negative scores because students do not know how to reflect on their knowledge. This is something that must be taught. They do not know how to do this at the beginning. And so they put things, and a lot of times they'll say, I'm extreme or I'm fairly certain. They're trying to go for the big points, and they're not actually thinking about this. So people are slammed on at the beginning, and I tell them over and over again, I go, the point is, if you want to get a high score, you have to get better at reflecting. Do you really know it or do you not know it? And I'll try to show you some of the math here in a little bit about that. If you get it wrong and you say you're extremely confident, okay, that is a student that's trying to think that they can beat the system somehow, or it's someone that actually does have a really strong misconception or a delusion about this particular subject. So that's one thing that's important about CBMs, that a lot of times it'll show students what they have misconceptions about. They were extremely certain. How could you have been extremely certain and not gotten it right? So you take a -6 if you do that. If you say you answer the question, you say I'm extremely certain, but you actually get it wrong. So how do I use this in my class? I don't use this on regular competencies. You could, and I'll show you how you could do that. I have, for the last several years, I've created what is called a QED exam. And really what that is, it's my end of the year final exam. It's all kinds of very similar problems to what the final exam is. And a lot of the problems are actually what they're going to receive eventually on the final exam. The final exam is not a CBM. It's just, answer it and get a point or not, for just like regular kind of test. But my certainty-based exams are basically my final year exam, and I give it 6 times on the year, 3 times each semester, for no grade whatsoever. It's no grade, but we have QED days where everyone takes basically the final exam early, and we see how well they can do on it. And it is CBM, so they have to specify how certain they are. Well, of course, it's covering the entire year's material, And so the first time we take it, you'll see here in August, I mean, that's the first day. The first day of school, I actually give them this exam to see, is there any physics that you already know from the very beginning? So we set a baseline the very first day. Of course, they don't know hardly anything on the exam, and so the score is obviously really, really low. And then we take it again in October, we took it again in December, and we just took it recently on February 9th. And we hopefully see our average scores on the CBM exam going up, which we do. And last year, they all went up every single time because we're gaining more knowledge, and they are getting better at reflecting on what knowledge they have. By the time we've taken it the fourth or fifth time, students realize that if they want to get a high score, they have to get better at just really honestly reflecting on their knowledge. And because this isn't a grade or anything else like that, a lot of students, I think, do a pretty good job of trying to just, use this assessment as a learning experience. And they really do. I have students that miss that day, and they come in and say, "Do I have to make the QED exam up?" And I'm like, "No, you don't have to if you don't want to. It's just a kind of a thing, learning experience." I usually always have students that'll come in and they'll schedule a time and they'll come in to take it because they don't want to miss one of the 6 times to basically have another shot at the final exam and to see where they are and how well they know. They plot their own scores in their notebooks. I have a place for them to always record their QED exam scores to monitor their own growth throughout the year. So this is I have this up on the bulletin board. The red is the average score. It's a 30 question test, but I've tried, in Moodle, I can make it be out of like 33, so it scales it out of 33. And the reason I did 33 is because, if you're extremely certain and you get them all right, you could get 3 times 33. You get 3 points for each one, so it'd be a 99, which is really close to 100. So really whatever score Moodle tells them they got on it is technically their score. So you'll see that these scores, they seem extremely low. They're always going to be low because for a CB exam, people, you don't say you're extremely certain on every one pretty much ever. So like right now, the last time we took it, our average score was a 27. The highest average score we got last year ever was, I believe, a 30. So we're almost ready to beat that this year. And that's another thing I do. I have last year's graph up on the board also. So every time we take it, we look at last year's average score, and that's what we're trying to beat this year. And so far this year, we have trended about 2 points higher than last year's class on every single one. So every single test, we've actually beat them. I also, as another incentive, and that students like this, I put on the high score on this particular QED exam. So this is the high score that a student got. Another interesting thing about that is last year I had, and the high scores all went up last year too, but the high scores last year, all 6 was a different student. This year, all 4 of these have been a different student also. So it's kind of spreading the wealth. It's interesting how that's turned out to be like that. So we take this 6 times. They graph their own, they graph their progress in their books, but it's not for a grade. We make a big deal out of it on QED exam days, and students seem to really put a lot of effort into it, and they get really, really good at reflecting what they do or don't know. And then we start seeing discussions that they're having, which are really interesting. And recently there was a discussion amongst some students, and they were like, "Do you ever put a certainty level of 2? Seemed like I never do that anymore. I used to just kind of always have different certainty levels, but I hardly ever put a certainty level of 2 anymore. I put a 1 or I put a 3." And they were all talking about that, and they were all agreeing that, yeah, they hardly ever use a 2 anymore on this thing. And so I showed them that there's a mathematical actual reason for that. What that means, that discussion means, is that they are getting really good at understanding their knowledge and what they know and what they don't know, which is a real important skill. Very few people get to the point where they can really honestly reflect about about their knowledge. And so I'm going to show you this graph here, and don't run away. It looks scary. It's not scary at all. It's actually pretty easy, and I think we can make sense of it. On the y-axis here, we have the points, the amount of points you could get. And if you remember, if you're extremely certain and you get it right, you could get 3 points. That's the maximum you could get. If you're extremely certain and you got it wrong, then you have a -6. So all I've done is I've just put the amount of points down here on the side that you can get, a -6 all the way up to a 3. And then down here is the your confidence that you're going to get it right. And of course, if you get it wrong, then that's 0%, and if you get it right, that's 100%. So this is just, getting it wrong up to getting it right. And so this would end up being, your percentage on how confident are you on that you're going to get it. So all we have to do is graph 3 lines for each certainty level. So let's see if we can understand this. So if you say you put a certainty level of 3, which means I'm extremely certain, okay? Well, if you get it right, which would be 100%, what was your score? It was a 3. So I put a point there. And if I said I was extremely certain but I got it wrong, what was my score? Well, it'd be a -6. So here's 0%, so that means I got it wrong. And there's -6, so I put a point there and I connect that line. So that red line represents the extremely certainty level. What if I was fairly certain, a certainty of 2? Well, then if I got it right, 100%, then I got 2 points, so I'll put a point there. If I got it wrong, I got a -2, so I put a point there and I connect that up. And if I was not certain at all, and I get it right, 100%, I got 1 point, so I put a point there. And if I didn't get it right, I got 0 points, so I put a point there and I connect that line up. So then what we have is a graph that tells you really what certainty level you should put based on how confident you are. Think about this graph, the x-axis down here is how confident you think you are. And you'll see that you should put whatever line is the highest, because that's the most amount of points you could possibly get. It's higher up here on the point level. So what that means is that from 0%, all the way up to about 2/3 or 67% right there, that you should choose which level. You should choose the blue line, which is certainty level of 1. So 0% all the way up to 67%. When you take a question, answer a question, if you feel you're from 0 to 67% confident in it, you should go ahead and just put not very certain. Now, how do you know if you are? How do you say, well, I'm 52%, confident? That comes with practice. That's why we do this. That gets you get better at knowing if you are truly in this range or not. You can't really say, well, I'm 53.2%, confident, but you can start getting a better idea if you're somewhere in this range, and if you are, then you need to put a 1. Now look at this right here, from 67% confident to 80% confident. The black line is on top, which means that certainty level of 2. Okay, now that's a really small range. What does that mean? It means that you're probably not going to put 2 very often. And that's what the students have actually realized after much practice and reflecting with things, is they realize, I don't hardly ever put a 2 anymore. That's because they've gotten better. They realize where their percentage is falling, and so very rarely do you put a 2. Usually I have a student maybe put 2 once or twice on a test, which is about the percentage you would do with 30 problems. And then 80% to 100%, you'll see the red line is on top. So if you are 80% to 100% confident, you are pretty confident. You would be well off if you put a certainty level of extremely high, 3. And then you can get the most amount of points for that. Hope that makes sense. Hope that wasn't too scary on how that works out, on what percentage you should be able to kind of reflect on. So I want to look at a couple of CBM exam results in Moodle and show you kind of how it works on this, because you can, it's a quiz in Moodle that you can set to be certainty based, and it'll calculate everything for you. So you'll see that this is the 4th attempt. This is one of the attempts last year, a 4th attempt. And they got a score of a -4 out of 30. Remember, I had 30 questions. So obviously they ended up with a negative score, which is not good. Now, I remember I said I made it out of 33. So they ended up getting, so it adjusted everything, and they technically got a -4.4 out of 33. This score could be a maximum of 99 out of 33, because it'd be 3 points for each one. So it looks a little weird when it's scored that way, but they could get up to a 99. or they could get, down to a really super negative score, -6 times 30, so. Okay. So down here is kind of an important thing. Actually, their accuracy was 40%. That's actually their real grade. So you could do certainty-based things for real tests and just not use the certainty-based stuff. Maybe it'll help them reflect a little bit more. But this right here, accuracy, would actually be what their grade is. They got 40% of the questions right. Okay. But they still got a -4. How did they do that? Well, how did that happen? Well, if you look down here at the responses, they didn't answer 2 at all, which usually happens now. They did answer that they were extremely confident on 12 questions. 12 questions they said they were extremely confident. And how many of them did they get right? They only got 58% of the ones that they said they were extremely confident on, which is not good, because that means 42% of the problems they took a -6 on. Okay, now what range should they be confident? They should be getting 80 to 100% of the ones that they answered 3 on correct. Remember from that last chart, they should be getting 80 to 100% of those correct if they were doing well on this. What does it say? You were overconfident using the certainty level. What they're saying is you're not reflecting very well on what your knowledge is, or you have some strong delusions or misconceptions about some things. On 18 questions, they put not very certain, and they got 28% of them right, which is totally fine because the range is from 0 up to 67%. You should be putting C equals 1, so they were okay on this particular certainty level. So you'll notice here, it's kind of interesting, is the way that this could be used on all tests is it tells you your percentage, but then it docks you, it calculates a CBM bonus. And if you don't reflect well at all, it actually gives you a negative bonus. So it would lower your score from what you actually got. And you could choose not to ever add on the bonus if it's negative, and they could just get what they got. But sometimes, though, people reflect well, and then it would actually give them extra points above what they actually got on the test. And so they would be rewarded for reflecting well. So this could be used very well on regular tests if used that way, I think. Here's another example. This person got 59.4 out of 33. They did very well. I think this is the high score probably on the 4th test last year. They actually got 73.3% of the test right. And this is great because there's still 2 more tests, which means we haven't done like 5 units in physics. And they're already getting a 73.3% on this test. Really, really good. They got a CBM bonus of 8.7% because they did a really good job of reflecting on what they knew. So they would technically get an 82%, even though in reality on the test they only got a 73.3. So that'd be a really good bonus for them on learning how to reflect on their knowledge. Let's see what they do. So 16 times they said they were extremely confident, and they got every one of those right. That means they are doing a great job at reflecting and understanding their knowledge. 16 times they went with the risk of putting a 3, but it wasn't a risk because they actually really did know it, and they knew that they knew it. So they were okay on the certainty level. 14 times they put a 1, and they got 43% of those right. So it's a good thing they put a 1 on it. And so the optimal range is 0 to 67, so they were totally okay with putting the 1 on all those other ones. So that's a very good, that's a person that knows a lot of things, and they know a lot of things, and that's great. So kind of in conclusion, some of the reasons we use CBM and what it's good for is, and this is I like this kind of graphic here, so I'm kind of threw this in here. We all have different nuggets of knowledge. We have different things. The important thing is to make the connections between them. That's how it's networks of understanding. Understanding is attaching these nuggets of knowledge together. And people that can do this, that can take different ideas and see how they're related, that is what real knowledge is, an understanding of a concept, real deep knowledge and understanding. And a lot of people try to do that, but what CBM does is it really forces you to do this. It helps you do this because you're going to make an inference about the evidence that you see, but you have a problem, and you're going to make an inference on that. You're going to state, normally you would just guess one of them, But in this one, you also have to state your confidence, your degree of belief in that is correct, and then you make your choice. And when you're doing that, confidence-based marking, CBM, it places a greater demand on justifying and stimulating your understanding. Okay? So if you try to justify your answer, it stimulates you to understand. It actually makes you try to build these networks between the nuggets of knowledge that you have. I think that's really important, and that's something that we should always kind of think about. How can I not just give them nuggets of knowledge, but how can I make these connections for them? How can I help them to get these connections for themselves? And one of the ways to do that is CBM marking, because it helps them then try to make these particular connections. Justifying your answer will stimulate your understanding of what you're learning. So CBM exams, to me, are learning experiences in themselves. They help the student focus on the learning. So why CBM? Lots of different reasons. Here's a few. Requires students to reflect more carefully. It rewards recognition of uncertainty. It highlights misconceptions and delusions that students might actually have, which is incredibly important in science so that we can break those down. It's really difficult to break those misconceptions down and to get them thinking more towards the other end of the spectrum of knowledge. It engages students more. They're actually more excited about it. They do like to do this thing. It encourages criticism of questions. This is kind of a interesting one that kind of comes out that is more for the teacher. A lot of times you'll have students they'll say, "Hey, on this one, here's my understanding, and here's what I tried to connect together." And the way that question was worded made it seem like this wasn't the case, and they can have a really good grasp of reflection on saying that the question isn't good. The question isn't really written well, and it could mean something else. And so I have to, as a teacher, go look at that question and say, okay, I see how they could take it to mean that particular thing, and maybe rewrite a question or not have so many ambiguous type of questions. So it actually can criticize the question that we've written, and then we can work together on helping each other. And it enhances self-assessment as a learning experience in itself. So helping students to learn to reflect on their knowledge is a great learning experience all in itself. So I hope that helps you a little bit more with what CBM, or certainty-based marking, is, and how it can be good for students and help them to gain knowledge and make the connections between the nuggets of knowledge that they have in their life. So I'd like you to try the CBM experience, as I'm calling it, and if you can go to this link, it's on Moodle. If you can log in to Moodle and then click on this link, I have a separate little course set up that all it has on it is a quiz, a CBM quiz. So under course administration, you can click enroll me, and then you can just go ahead and try to take the quiz. It's just 10 multiple choice questions of random things. It's not a really big in-depth test, but you also have to state your certainty. So it'll help you have the experience of what it's like to actually put an answer to the question and then be forced to kind of think about it a little bit. So that's the presentation. I hope you enjoyed it. I hope you learned some things that maybe you can apply in your classroom. Thank you.